Hi, everybody. In this unit, we're going to look at 1.4, which is on the complex number system. So in the next section, in 1.5, we're going to learn how to solve things with squares in them, different kinds of quadratics. And sometimes what happens when we're solving quadratics or even other kinds of examples, we end up getting square roots of negative numbers. And we know that those are not real numbers, but it'd be nice to have a way to work with them, right? I'd like to have a solution to something like this. So what we have is we have instead the complex number system, which also contains the real numbers as well. It's an expanded system, and I'm going to talk about that today. So the first thing you need to know is the imaginary unit I. This is sort of the base of that complex system. And it is defined as the square root of -1. So we're creating a symbol here to represent the square root of -1. And obviously, if you square both sides, I squared would be -1 exactly. A complex number is a number of the form a plus bi. That I is that imaginary unit, and a and b are real numbers. This here, this a plus bi form is also called the standard form. And when a complex number is simplified, let's just say it is in the standard form. Now, A is said to be the real part of A plus BI, and B is said to be the imaginary part of A plus BI. I will note that in some texts, they use BI as the imaginary part, but it's usually more standard just to use the numbers out front. The other thing I want to note is that the set of complex numbers does contain all real and all imaginary numbers. So it's a larger set beyond the reals. So real numbers are included because if B is 0, right, if this is 0 here, then that part just goes away and you're left with just that A. And if B is not 0, so if you actually have a number with the imaginary unit, then you do have an imaginary number. They can be written like 2 plus 4i or 16i as examples. When a number is written as the second way without a real part, then sometimes we refer to this as a pure imaginary number because it has no real part. Okay. So before I go on, I just kind of want to break this down a little bit further. A lot of students really have trouble with not working with complex numbers, but understanding what they are or what the system is. So what we've done is we have a system of numbers beyond the real numbers. So complex numbers are all numbers a plus bi. But they include both real numbers. Okay, so this happens when b is equal to 0, and they include all imaginary numbers. And this would happen, obviously, if b is not 0, so you actually have an imaginary part. So for example, the number 6 is obviously a real number, and you could write it as 6 plus 0i. So it still falls under complex numbers because we can write it in that form, but of course, it's also just a real number. -10 plus 0i. Again, it still fits the form. You can even include fractions and decimals and so on. So all your real numbers are included under the complex number system because you can always let that imaginary part just be 0. So again, it includes all the things that you already know. So the real numbers, your rationals, your irrationals, your integers, your whole numbers, your natural numbers. So all those sets that you've already learned in the past, those are all included under the real still and also under the umbrella of complex numbers. For imaginary numbers, again, they're still complex numbers. It's just that the b part is not 0. So you actually have an imaginary part. So for example, something like 7 plus 10i, or -8 minus 5i, or 1/2 plus 1/2i, or 6i, or -1/3 i. These are all examples of imaginary numbers. The 2 at the end, when that a value is 0, we do also call those pure imaginary numbers. So Complex numbers covers both groups. So real numbers are complex numbers, imaginary numbers are complex numbers. They're all complex numbers. And then sometimes we'll say specifically imaginary number if it does actually have an imaginary part. So you do want to be a little bit careful. A lot of textbooks and people just use complex numbers and imaginary numbers interchangeably because they are the same thing. It's just that with imaginary numbers, you obviously have a real, no real part. Sorry, that's for the pure. So for imaginary numbers, excuse me, you have to have an imaginary part. That's what I was trying to say. But they're all complex numbers. So again, if you hear someone say complex number or imaginary number, usually they mean the same thing, even though technically complex numbers are the overall umbrella for everything. I would caution you too, a lot of times when you do online searches on complex numbers, again, those definitions really are a little loose sometimes. Like I said, sometimes people say complex, sometimes people say imaginary, and they distinguish between different things. Some people say pure, some people don't. So I would go with the definitions in our textbook. Those are the ones that you want to follow, and the ones that are, pretty well agreed upon. But I'll just warn you that sometimes when you look online, the definitions get a little bit mixed, depending on who's actually presenting. So you want to be a little careful there, because sometimes there's, maybe people who don't know as much as they should who are presenting, and they may mix up some of those terms. So just be a little careful. Now, the nice thing is that they're actually pretty simple to work with. So you can add, subtract, multiply complex numbers, very similar to how we add, subtract, and multiply variables. So I is not a variable. It is a number. It is the imaginary unit that represents the square root of -1. But when you add, subtract, and multiply, the processes work very similar to variables. So just like you would combine like terms, you would add or subtract the real parts together and the imaginary parts together. Just like when you multiply with variables, if you multiply x times x, you get x squared. If you multiply I times I, you get I squared. So they work very similar, but you do want to remember that I is not a variable. It is a number. It's an imaginary unit. Division is a little bit different. So that's where we deviate a little bit. So what we have here is another definition, and it's called the complex conjugate. So the complex conjugate of a complex number, a plus bi, is just a minus bi. So only that middle sign switches. And if you have a minus bi, its complex conjugate is a plus bi. Sometimes we'll just use the word conjugate there, so you can know that those are interchanged as well. If you don't see the word complex, it still means the same thing. And to divide complex numbers, what we're going to actually do is we're going to multiply both the numerator and denominator by the conjugate of the denominator. So we don't really have a long division process for complex numbers. Instead, we use the conjugate to help clear out that imaginary value in the denominator. And I'll show you how that works. All right, let's start with the easier ones first, though. So adding and subtracting really just work very similar to combining like terms. So here I have my two complex numbers. I have a plus sign in the middle, so I don't really have to distribute that plus sign. It's really just 5 minus 11i plus 7 plus 4i. And then what you're going to do is you're going to combine your real parts, right? So 5 plus 7 is 12, and you're going to combine your imaginary parts. So what do we have here? Negative 11 plus 4i, so minus 7i. Now, when you write it, you do want to write it in standard form. Standard form is a plus bi. So the real part goes first and the imaginary part goes second. If you write it in the opposite order, although it's not wrong, it's not in the correct form, so it will likely get marked wrong on my math lab. So you want to make sure you read your directions carefully and put it in standard form. Here, I do have a negative, so just like with a regular example, I'm going to distribute that negative through. So here it's going to become a positive 11 and then also a positive 6i. And then I'm just going to combine really my like terms here. So my real parts, negative 5 plus 11 is 6, and my imaginary parts. Now, just like with variables, if there's no number, there is a 1 there. So 1 plus 6 is 7. So 7i. And that's all for adding and subtracting. Again, multiplication works very similar. There's really not a lot of new stuff here, except for to recognize that I is technically not a variable, right? So what I'm going to do here, though, is I'm still going to distribute through 4i times 3. Well, 4 times 3 is 12, so this is 12i. 4 times negative 5 is negative 20, and I times I is I squared. So the only difference here you need to keep in mind is that I squared is negative 1, right? Because I is the square root of negative 1. So if we square both sides, then we get that canceling effect there. Oh, let's try that again. So when you have an I squared in your answer, you do need to simplify that. It's the same thing as negative 1. So I'm going to replace that I squared with negative 1. And then I'm going to keep simplifying. Negative 20 times negative 1 is positive 20. And then just don't forget to put this in the correct form. So the imaginary part goes first, and then the real part goes first, excuse me, and the imaginary part goes second. Here, you're going to use your FOIL technique that you have before, or you can use just the distributive property twice. So you're going to go ahead and bring that 7 into both pieces. So 7 times negative 2 is negative 14, and 7 times negative 5i is negative 35i. And then you're going to do the 3i next. Just be careful, it's a negative. So negative 3i times negative 2 is positive 6i. And negative 3i times negative 5i, well, I'm going to have a positive 15 and then an I squared. I'm going to keep simplifying. So I do have like terms here. So I can go ahead and add those together, negative 35 and then plus 6. Hang on a second, let me plug in my computer, guys. That was it. Yep, there we go. Okay. Okay, so negative 35 plus 6 is negative 29i. And then here, remember that I squared, you're going to need to change over to negative 1. And this is all being multiplied. So 15 times negative 1 is negative 15. And then again, I'm going to combine my like terms here. So I have negative 29 minus 29i. My real part is first. My imaginary part is second. So adding, subtracting, and multiplying complex numbers, really, even if you didn't know what it was, you could still do it because it works very similar to variables. The only difference is, of course, just make sure if you have any I squareds that you're changing those over.